Hi everybody, a very good afternoon to all of you today. Welcome to our live hacking demonstration today, entitled 5 Vulnerabilities in Your Apps Before Hackers Do. Hi, my name is Paul and I'm the editor of CDOTrends, and I will be with you for the next hour or two. Now, a quick backgrounder before we begin. I think none of you will disagree to this, right? That web apps are everywhere. From e-commerce, government agencies, to your in-house CMS, we use them every day. Unfortunately, this makes web applications a vector of attacks for hackers. But how do web hacks happen? And what are the security implications of a successful exploit? For today, we will, or rather not me, Lawrence over here, will be doing a live hacking demonstration of common web exploits in action. This will hopefully open our eyes and also offer some context as to how implementing security during the deployment phase can make a difference. So, what's going to happen next? In just a moment, I'm going to introduce you to Lawrence Croter, Head of Solutions Engineering for the APAC and Japan at Snyk. Now, Lawrence will walk us through a short 10 minutes presentation to set the context of what he'll be demonstrating later. This will be followed by the live hacking proper. Now, there'll be a 10-minute Q&A segment right at the end where we can take your questions. Now, if you have any questions, please fire them away using the Q&A box or by directing it as a comment to myself. Now, one quick note, Lawrence will be demonstrating 3 types of common attacks today, and there'll be a few minutes between each demonstration where I can direct questions to him. So you don't have to wait to the end to type in your questions, right? So we will address them throughout the session. So if you have any questions, please send them along at any time during the session. So enough of me talking. I want to hand over the time over to Lawrence right now. Over to you, Lawrence.
Thanks a lot, Paul. And thanks everyone for coming. Happy Friday. Hopefully we can kickstart your weekend with a bit of live coding and live hacking for a bit of fun. I'm going to cover, as Paul said, just a few slides, a bit of context setting, but most of today's session will be all hands on. So get your questions ready and let's go. I'm just going to share my screen here. You see that okay, Paul?
Looking good.
Perfect. So my name is Lawrence Croter. I work for a company called Snyk. Hopefully most of you have heard of that. We're pretty synonymous with this purple color you see here, actually. So you'll see 2 themes in this presentation. One is purple, the other one is dogs. I've got the dog logo here, but we have Patch, his name is, who's our sort of the Snyk logo. He's obviously a security dog, Doberman, if anyone's wondering what type of dog, but he's going to protect your code, your infrastructure, and your containers and all that, as we all see. My background is mostly in software development. Sort of over the last 20 years, been working on both client side and vendor side. Recently sort of got into app security as well, but there's definitely a huge crossover into sort of agile software development, cloud native development. Snyk is about modern DevSecOps and integrating security as far left as possible in the security in the software development lifecycle, which we'll talk about. So with that, let's go. So I just want to sort of do a primer on what is DevSecOps, what do all these things mean, DevOps, CI/CD, DevSecOps together, like how do you do continuous security, in other words. A little bit about the Snyk platform, and then we'll jump into the live hacking. Right, so I mentioned shift left. You may have heard of the term. If you haven't, it's really about pushing the security concerns to the very far left as possible, i.e. where developers are writing the code in the IDEs, right? So they can get real-time information around not only the code that they write, but other sort of application specific components like containers or infrastructure as code, as we'll see as well. But that really is not enough. You can't just take a bunch of tooling and shift left and expect to have continuous DevSecOps or continuous security. There's other things you need to do as well. Traditional security tools focus on detecting and reporting vulnerabilities and create sort of audit reports that and enable sort of gates that sort of slow down the development process. and stop developers from releasing software to production. Which is okay, but the problem with this approach is that it runs counter to the fast, iterative, multi-deployments a day DevOps processes we're used to, so that companies can innovate, they can compete in the market, and sort of remove competitive risk. But what happens is people work around this, creating unnecessary security risk, i.e. sort of introducing security at the very late stages of development. Obviously is very costly, but also risky. So a successful approach needs to enable security to be built in continuously in the DevOps model. And the responsibility for security has to be initiated from development, with the application security team acting, in this case, in a supporting, advising, governance type role, which is very similar to if you wind the clock sort of 10 years ago, what happened with DevOps, right? The operations team played a different role moving into sort of DevOps era, and the same thing happening is now with security in DevSecOps. And as you can see from the survey here, the survey is called DevSecOps Insights 2020. So this is from last year, but it's still relevant because folks were still thinking about it then. 81% of folks believe developers should own security, but the challenge they have is trying to make this work. So hopefully I can share some insights today to take back and practice in your place of work to try a few things out. So the modern application has changed, and fundamentally developers who used to just write code and sort of pass it on to ops to deploy their applications, their job was sort of done. But if you look at that sort of iceberg here, just the tip of the iceberg is, the custom code or the proprietary code, right? And we see that only to be about sort of 10% of an application. That is the, code that the business logic that makes your applications unique and your business unique. So it's very important, but it's only a really small portion of the overall application context. What we see is that 80 to 90% of those applications is made up of open source libraries that you import. So this is a huge area of concern for companies to keep themselves secure, because it's not only the dependency that you import, it's those libraries may include other dependencies, which have other dependencies, and it goes on like that, which you can imagine is thousands of lines of code, which probably contains vulnerabilities. It's said that 80% of all vulnerabilities live in what we call the indirect or transient dependencies. For example, you may have a small application. The one I'm going to show actually soon is about 100 lines of JavaScript code. And it's a to-do app, okay? And you may import, say, 20 libraries, but those 20 libraries may import thousands of lines of code because they are dependent on other libraries. So what you end up having when you deploy it to production is thousands of lines of code you didn't even write, and you don't know where it came from or was downloaded from the internet. So that's a huge sort of black hole where lots of vulnerabilities can live. So you definitely need to look into what is actually running in your applications. Next, most modern applications will use containers. Of course, Linux containers. There is some Windows containers, but most of the containers out there are Linux, which contain obviously hundreds of Linux packages, which also contain vulnerabilities. So we need to make sure that the containers developers are constructing have no known vulnerabilities before they release to production, or at least low vulnerabilities, which is acceptable to the business. But developers are simply unaware of the vulnerabilities that lie within the base images that they use from, say, Docker Hub. So you definitely need to scan those before you release to production. And then finally, sort of the number one cloud vulnerability at the moment is around misconfigurations for your IAC scripts, so your infrastructure as code scripts like Terraform, CloudFormation, Kubernetes, YAML files, etc. If you use a lot of the default settings, which is fine for development to get going, but if no one changes those and deploys into production, you're leaving yourself exposed. Things like inadvertently leaving security keys in the file, opening network ports inadvertently, running as root or a privileged user, exposing F3 buckets, stuff like that, which is pretty easy to do. And in some cases, it's just a flag that you can set to make sure that those things are secure. But they get forgotten because it requires manual intervention. So you need something that's going to protect you when you deploy your infrastructure as well. And what I want to summarize here is that what's changed really is that developers are owning more and more of the stack. And it really goes down to this picture actually, where if you look at a standard repository in GitHub or GitLab or whatever Git repository you're using, most of the assets are checked in to the same repository. You can see here, you've got the code, which is Ruby code. You've got a Docker file to define the Docker container images. You've got YAML files, right? And of course, you've got open source libraries defined in the package manager, like a package.json, for example. So all those things are sort of owned and managed by the developer, and they may not necessarily understand the security implications of those, right? But it's a huge ownership shift. I talked before about sort of security shifting left. I can also talk about developers shifting right, which means owning more of the development and deployment stack that they never had to do before. So that's what's really changed. Now, in terms of Snyk, what we provide is application security platform, and we really focus on sort of that developer ecosystem. It's a developer-first security platform. Frictionless, intuitive for developers, works directly where they are into the tools they use, IDEs, CI/CD, etc. Provides them sort of actionable insights and fixes, which are prioritized. So it does all the heavy lifting for them when they need to fix vulnerabilities and issues. A lot of the tools, as I mentioned before, just provide a report, and it's up to the developer to go off and sort of sift through thousands of lines to work out where the issues are. But here, we can issue a pull request, for example, which the developer just needs to sort of accept or reject, which has done all the hard work around which libraries needs to change, which code needs to change, etc. So that's what we mean by developer first, because Snyk is all about developing fast. We don't want to slow you down, but in a secure way, right? The next piece is around the security intelligence or vulnerability database. So it's built on industry-leading vulnerability and rules database maintained by a dedicated research team that combines like public sources, contributions from the developer community, proprietary research, and machine learning to continuously adapt to the changing and expanding nature of security threats. If there's a zero-day vulnerability and one of our customers is running an app in production, they'll get notified and they can do a patch immediately. We talk about this concept about continuous security or integration with the SDLC, right? So you'll see a picture in a moment where Snyk is integrated at every stage of the SDLC, from the IDE to the source control to CI/CD to production, so that we can check various components along the way, but also recheck things, because there is a chance of configuration drift as well. You want to double check everything all the time, but you want to continuously baked into your pipelines. And there's a piece around governance, right? So obviously for the enterprise, we want to provide sort of enterprise reporting, policy management across teams and organizations. So you can set sort of team-wide rules on how to deal with different vulnerabilities, of different issues that you might have. But most importantly, this is all sort of baked into a single platform. And what's at the center of the platform is our core 4 sort of capabilities, which is Snyk code. That's for your static code analysis, so a SAS tool. Snyk open source is going to check all of your direct and indirect dependencies in your applications using the package manager. And we support, most of the major languages out there. We have Snyk containers, which is going to scan your Docker file, or scan actual images deployed on a container registry, or maybe just your local file system, or even in Kubernetes, right? So you can sort of retrospectively scan images deployed in a production cluster of Kubernetes. And then Snyk IAC for infrastructure as code, where we support things like Terraform, CloudFormation, Kubernetes YAML, Azure ARM, etc., where we're checking to see if there's any misconfigurations in those files. So that's sort of the Snyk platform in a nutshell. As I said, this is how we integrate into the full SDLC. Into the IDEs, we support IntelliJ or the JetBrains suite of IDEs, Eclipse, Visual Studio Code. So most of the major ones for the different languages where you can get real-time information. You'll see it in my demo later. We support most of the major Git source control systems, so GitHub and GitHub Enterprise, GitLab, Bitbucket from Atlassian, Azure repos, etc. Most of the CI/CD platforms like Jenkins, Circle CI. But if you're using one that's less popular or not supported by us yet, then you can use the sort of CLI to get the same effect. It's a very powerful CLI, which you can integrate into, say, a Docker image in your CI/CD pipeline. And then I also consider production as part of the SDLC as well. And what we do there is two things. One, we will monitor applications deployed in production. What we do is we take a snapshot. Every scan that we do, we have a snapshot. So we can retrospectively go back and say, hang on, when you deployed this application, there's now a new vulnerability that's hit our database. You need to take immediate action and do a patch. Secondly, we can connect to production systems like Kubernetes or AWS Lambda to actually scan for vulnerabilities in those systems live. And we've also introduced something recently as well called drift detection, where we're going to find that if your desired state is different to your actual state, we can provide some remediation advice on how to fix that as well, because there are security implications with that too. So I just want to leave you, before we get into the live hacking, with the sort of ecosystem that Snyk supports. I mentioned sort of the IDEs, the source control, CI/CD, runtime, Kubernetes, Lambda, Docker, etc. The different container registries out there, and also issue or bug management systems as well, like ServiceNow, Jira. And you can use the Snyk API to integrate into various downstream systems. We also have a webhook capability, so you can send alerts, for example, to Slack. I'll just pause there, Paul, see if there's any questions before I sort of jump in at some of the demos.
You can send in questions anytime using the Q&A button, or you can send in through a direct chat message directed at me.
No questions?
I think we're good for now, Lawrence.
All right. Let me just go back to my screen then. Can you see that?
Looks good.
Let me put that in full presentation mode, I guess.
Yeah, that's great. Oops, it's gone again.
I need to see the other tab, so I'll just leave it like this, I think.
Right.
Yeah, so the first sort of hack I want to do is called directory traversal. And you can Google it, otherwise known as CWE22. Common weakness enumeration. So you can look that up either on the OWASP or the MITRE organization. It's quite a common one. So basically how it works is, you can see as part of the image here, if you put in sort of slashes in the URL, you want to try and go back a directory. So similar to if you're on a file system on Linux, you need to go back a directory, you can do // because obviously most web servers are Linux-based, so you can sort of exploit the runtime environment to sort of simulate traversing around the directory system of the operating system, right? And so why would hackers want to do this? They want to steal information. Predominantly it's read-only, so they can't actually write any information, but in that little picture there, you can see that he's sort of got to the etc. password file, which I'll demonstrate that as well. Which is kind of interesting, obviously, and you'll see I'll be able to look at various other configuration files on my application on my host machine, which could have sensitive information, like passwords or whatever in those directories. So pretty bad. Now, what I'm going to do is I've got a small to-do application over here, and it uses a library in npm. This is a Node application, which is used for serving static pages. So let's have a look. This is a blank screen at the moment. I can sort of add things to it, right? Get milk, what have you. Pretty basic. The back end is MongoDB. But if I click on this link here, you'll notice, obviously, it serves HTML page. Now I can try and do // here, like in the image that we saw. I think the browser is smart enough just to sort of redirect back to the home page. Okay. What I actually need to do is do it from the command line, where the browser is not sort of interrupting my request, if you will. All right. So let me just jump over to the command line. Can you see that okay, Paul? Is that big enough?
Looks good over here.
Okay, good. Let's get rid of that. All right. Make it full screen. So I've got some scripts here to make it easier for me. So what I want to do is run a series of curl commands. So before I do that, if I just type curl and then that URL that I had before, I just get the same thing as I did on the homepage, right? So just sort of the baseline test, right? Now, what if I wanted to sort of go back a couple of directories? So this one here, try to do the traversal hack by doing // like that. Nothing really happens. It just takes me to awesome to do, which is sort of the same thing that happened here, right? If I try and do // just takes me back to the home page. Okay. So it didn't work, not that interesting. But I know there's a known vulnerability in that ST library that doesn't really handle escape characters. So what's another way to represent // Well, it's %2e. Hackers would know this stuff, right? As would developers. If I try this time, I can actually list all of the files that are deployed at the root of that application. All right, so which is kind of interesting because now I can see, oh, this application is using Docker. So let me print out the Docker file. That's quite useful. I can see what other software is being installed on this container. What else can I see? Let's see. I can print out, say, the package.json file here, which is going to tell me what other open source libraries this application is using. So as I said, there's probably 20, 25 here. If I know of any other exploits that are in, say, NDM zip, which I know there's a ton, I could try those exploits too, right? So let's go back here. So now let's do something a little more interesting. Let's try and get to the etc. password. So if I type this command here, I can actually print out the etc. password file. Now, I think most modern Linux systems don't have the passwords in plain text. They're encrypted, but using a few techniques and a few other files, you can get the shadow file, for example, on the OS. You could decrypt some of these passwords and actually then do some real damage, right? But and this is obviously a Mickey Mouse application. I was going to hack into a live website, but I think I'll get in trouble for that. So I just wanted to do a sort of a simple demo app to prove the point. So that's the first demonstration. Any questions so far? Let's go back to here. Any questions on directory traversal?
Well, I think, Lawrence, it's kind of scary, right? I mean, when you're able to browse through the other packages that in use on the web server, that, are there even tools that can do that automatically? I mean, you make use of directory traversal to basically, look at other files to figure out what packages you're using, and from there try to search out other exploits that might be possible.
Oh yeah, I mean, hackers would definitely have scripts to do it automatically. There'd be sort of exploits or malware out there in the wild that can automatically feed this information back, through some sort of reverse proxy or SSH tunnel sort of thing that goes undetected. I've sort of done it manually here, but yeah, that would be fully automated by hackers.
I mean, you demonstrated a really simplified application, but does it mean that any application that you roll out on your website, has a potential for exploit? I mean, no matter how simple it is.
Well, I mean, depends how good the security posture of the team is, right? If they keep their libraries up to date and scan for known vulnerabilities, then they're going to have a much better chance. But I would say that no application is foolproof, because new vulnerabilities are coming out every day, and you can't really stop everything going to production. This is what I said before: is you got to sort of work out the balance of risk versus maintaining innovation. So maybe you would accept sort of low, medium vulnerabilities to go out to production. You'll fix them, next sprint or what have you. But sort of critical high vulnerabilities where there's malware or exploits out there in the wild specifically for that CVE, then you want to fix it immediately, because it's very easy for hackers to do what I just did.
Right. Thank you, Lawrence. We might be good to go. I think we don't have any questions at this point, but if any questions, please send them on to me.
Let me see if I can get this in full screen. If I just...
Right.
Oh, there we go. Is that better?
Yep, this looks really good.
Okay, so the next one I want to do is called, by the way, the audience is quiet. Well, I'm surprised there's no questions.
I think they're deep in thought right now.
What's that?
I think they're deep in thought.
Oh, okay.
I know about directory traversal, right? But it wasn't clear that how it could be exploited to learn a lot more about the web server and potentially exploit other aspects of it.
Yeah, exactly. I think a lot of hackers would use a combination of these things together in order to achieve their objectives, whatever that may be, right? So the next one is cross-site scripting. This is a well-known one, and hopefully most people have heard about it, otherwise known as CWE79. Part of the OWASP injection family of exploits, or vulnerabilities, I should say. So here, what happens is a hacker can inject malicious JavaScript code, mostly JavaScript or TypeScript, into a browser, make a form or a post field where an unsuspecting user can click on a malicious link without knowing it, and then the code will actually look at sensitive data. Like obviously the main one will be the session cookie. You can imagine going through like a shopping cart process. They could get potentially a credit card number if of course it was in plain text, usernames, passwords, the whole lot, right? So this is a very well-known hack, and again in the to-do app that I'm going to demonstrate, it uses a library called Markdown, which is pretty common to do formatting within the form fields. Again, as part of the NPM ecosystem. So let's go back to the app. Let's delete my stuff from before. Go back to the command line here. So I've got some pre-baked scripts to help me. So marked Yeah, so just an example of Markdown. I think people would be aware of this. I can, bold the text, right? Pretty cool, but as you'll see, has some issues with it. So, the things you can do with Markdown is put a link in here, right? To go off and open up a website. Okay. Fine. Obviously, that link does not have access to the underlying browser information, of course, just an external link. So let's try and sort of hack this with JavaScript, right? So I just want to do a simple JavaScript alert just to show you that I can actually execute the JavaScript runtime on the browser. That actually didn't work, unfortunately. Again, a lot of the libraries fail to handle escape characters. So this is the same case here as well. So let's try the same thing. Here we're saying ampersand hash 58 is the same thing as a colon, right? And ampersand hash 41 is the same thing as a right-hand closing bracket, right? This is to try and trick the library to pass sort of commands straight through the to the JavaScript runtime on the browser. So let's try that. Ah, damn, that didn't work either. Well, I know that if I put this word in here, so the way browsers handle JavaScript is pretty loose. Like they will accept like missing colons, missing semicolons, and the reserved word this means I want to reference the current document object in the browser. So it's going to do its best to interpret that. So as a hacker, I know that I can sort of bypass even the fact that they are removing or checking for escape characters. I still know that I can go further. So that this here is the same thing as JavaScript colon this semicolon alert 1, right? So this does nothing, but is ignored by the browser, but it's important when the JavaScript gets executed. You'll see it. So let's copy that one over. Okay, now the link appears, right? And I can get the alert message. So I figured out how to bypass some of that checking, and I can put any code I want in there at all. And so some unsuspecting user will click this, and you won't get an alert, obviously. They want to go undetected and steal some of the user information. I'll just do another one here. Right? Just to prove the point. Hopefully that makes sense. Any questions on that one?
Does that mean that if you're able, you just demonstrated an injection of JavaScript code through a web interface?
Say that again, sorry.
Are you? I mean, I'm just trying to wrap this around my head, right? As a beginner programmer, right? Do you just demonstrate the injection of a JavaScript code to run on the users?
Correct. Yeah. In the context of their browser session.
Right. That means that in theory you can access any other of the data that is related to this session. Correct. Now, what are some of this information? I mean,
sorry.
In theory, what are some information that you could actually?
When you go to a website, the web server creates a session cookie. So in that cookie, it pins, maybe username, password. It might have a credit card number if you're going on an e-commerce site. All sorts of stuff. Personal information.
Wow, this sounds uncomfortable. And I presume this will be used with other exploits to basically funnel the information out.
Correct. Now, what I want to show actually is Snyk fixing this problem, right? So we've got the problem. Now let's go ahead and have Snyk fix it. So I'll do it for both of them, both the directory traversal and cross-site scripting. I'll fix it all at once. So
sorry, Lawrence. We had a couple of questions coming. I thought maybe I just put them live.
Yeah, go for it.
Yeah, because they are related to. So Leroy is asking, right? Is it only a client side kind of a problem? Would it affect the server side for cross?
No, it's only client side in this case. Obviously, the first one was on the server. This one is on the browser on the client side.
Got it. And another one is, wouldn't the browser block the exploit code sent out to different domains?
Potentially, but some of the libraries sort of. That's why I used this property. It sort of allowed me to bypass through the browser checking and pass through the code essentially.
Right. So in theory, the browser,
browsers are getting obviously more sophisticated, so some of this stuff will be blocked, but it is still possible.
All right, I think we're good for now. And Lawrence, there's another question. How does and given that you're gonna show how Snyk can preempt this attack, right? How is Snyk different from existing open source solutions such as SonarQube and other code quality assurance products?
Yeah, so most of the other products have like sort of point solutions or one or two solutions. Snyk is covering your open source, your static code analysis, your containers, and your ISE on one platform. That would be sort of the first thing. The second thing is the sort of developer-friendly sort of way that developer-friendly experience that we have, integrated all into the developer tools, does a lot of the heavy lifting for you, as you'll see, actually. It's probably a good segue into the demo because you'll see how easy it is to actually fix the problem.
Awesome. I think we are good for now, but keep the questions coming. Thank you so much for the questions so far. Lawrence, back to you.
Yeah, no problem. So this is Snyk, the Snyk dashboard. This is my application here, the vulnerable node app. You can see it on GitHub actually. And I can share this link as well if you want to. If you're quite welcome to go and try these examples out yourself. Maybe we'll share it at the end. So it's a public repo. So what I want to show is here. You'll notice that there's a whole bunch of stuff here. I won't go into all of it, but we've done the code analysis of the JavaScript. We've got the Docker file for the container. This is deployed on Kubernetes as well. We've got the YAML file for the Kubernetes deployment. And we've got the package.json, which is the manifest file for managing the open source dependencies. So let's go in there. Now, the first one was the directory traversal hack. You can see it here, ST. It's a medium severity, I would suggest, because it's read-only, not writable. I can't write to it, so it's still pretty dangerous, right? Getting all that information. You can see more detail about the issue, how it was introduced, what they're suggesting to do, upgrade to version 2.5 of the library, and some more commentary about the hack, right? So what we want to do is fix this vulnerability. Let me just bring up the other one first as well. So that was the cross-site, cross-site scripting in marked. Yeah. Again, this one is higher because obviously, you can actually do probably more damage and it affects customer personal information. So let's go ahead and fix this vulnerability. What this is going to do is raise a pull request on GitHub. So my cross-site scripting is there. Let's look for the directory traversal one. I think it's this one here. Yep. And go ahead and put those into a pull request. So what it's doing now is sort of talking to the GitHub API, creating the pull request as you see here. You can see what files have changed. So we've upgraded the marked library from .5 to .6, and we've upgraded the ST library from .4 to .5. Okay, pretty straightforward. As a developer, all I have to do is come in here and accept it. There's more commentary about the vulnerabilities, what was changed here. You get a good summary of what files were changed. We also need to update the package lock.json, which is the sort of result after the dependencies have been built into the application. And we want to merge this pull request. Let's confirm the merge. We don't no longer need that branch because we've put the code in that main trunk. First thing I want to show is go back to Snyk, and because of our webhook integration with GitHub, you'll notice that it has rescanned the project. So those vulnerabilities should no longer exist. You can see here tested a few seconds ago. See that? And if I go in and try and find those vulnerabilities, this is from a different library, cross-site scripting, but essentially they're gone. See, the ST directory traversal is gone. Other libraries have it too, but the one from ST is gone, right? So if I come back to my IDE here, what I want to do is update the project. And you should see this change here. Yep. You can see here that the package.json has changed. Now all I need to do really is sort of bounce the server, rebuild it, and redeploy. Should take a few seconds. Like that. Just make sure the website is up. Yep, we're good. Oh, you see that? It went away. See that? The gotcha thing went away. But I actually didn't want to show that, but that was quite nice as well. If I go back to some of those commands that I ran, so remember I tried to get the password here. If I run it now, I just cannot get that resource, right? And similarly here, if I try and put that in, nothing happens really. I can't, there's no exploit there. Make sense? So that's how easy it is to sort of fix the vulnerabilities with Snyk. Now, one last vulnerability, just conscious of time here, is the SQL injection. This is a pretty famous one as well. I think it was #1 on the OWASP list, but now I think it's dropped down #3, but probably one of the most common vulnerabilities out there. So here, a hacker can inject various SQL commands into a query string, and if the code doesn't handle or sanitize or validate what's in the string, it'll pass it directly through to the database. In other words, you can basically execute any SQL command, like drop table or delete, from table, or look up information, or in the case I'm going to use is actually bypass all authentication and log into a website without putting a username and password in. So again, pretty bad. So I'm actually using MongoDB. So this is strictly a NoSQL injection, but same thing. So what I want to do here is, I know that there's a sort of admin area to this website. Here, username and password. If I just put anything in like this, it just does nothing. It just takes me back to admin access. But if I actually use the proper password, let me get that here. Super secret password. So admin password. It just says admin access granted. Okay. So watch out for that. So again, I want to use the command line for this. So I just need to, yep. I've got some aliases here, so I can just type simple commands to make it easier, so I don't have to type the whole thing, but basically the just to show the sort of basic case of logging in is ns1, which is this command here. I'm using HTTP utility on the command line to execute what a user would do on the browser, right? So ns1, you look at the HTML, it says access granted, right? Because we use the actual username and password, right? Okay. So ns2, on the other hand, it's just going to use password. So that should fail, right? Sorry. Oh, sorry. I forgot to mention. I need to use JavaScript JSON JavaScript object notation in order to do the hack. So this particular one uses the super secret password again, just to prove that I can log in using a different method with JSON, because that's where the exploit is you'll see later on the escape characters within JSON. So that one works, right? Admin access granted. Now, here's where it doesn't work. We want to try, the wrong password. So ns3, it doesn't say granted, it just goes back to the home page. All right, I think we get that. Now, I know that some applications don't sanitize or validate strings being passed in. So I want to try and use, simple commands to be interpreted by the code, right? So in this case, here, I'm going to use $GT, which is another way of saying greater than. But what I'm going to say is greater than blank. So the username is admin, but the password is anything greater than blank, which is anything. Okay. So this should allow me to log in, ns4. And it does, admin access granted. Okay. And similarly, I can actually do that with a username. I can say the username is anything, the password is anything. Let me log in. ns5. Again, access granted, right? Hopefully that's clear. So I'm saying username is, actually you can see it better in text up here. Yeah. So the password is greater than blank, which is anything. So basically what it's going to do is pick up the first row in the database in that case. And the user is anything. So it's always going to return true. So always going to return a row in the database. So that's why I can get past it. Now, I want to show you, in this case, our Snyk code. So this is my IntelliJ IDE. I've got a plugin down here for Snyk. You can see that. If I just run a scan in my environment here, I can see the top one there is SQL injection. So this is where it passes in the user and username and password directly from the request body. So I'm not sanitizing the input from the user. I'm just passing it straight into the database method to be executed, which is very dangerous, obviously. And that's why Snyk has detected it here. Snyk code, it tells you, the sort of data flow, where the request is coming from. It also gives you examples on how to fix the problem. But I know what I need to do. I need to escape these strings in order for it to remove all escape characters. Okay. So let's rebuild the code and redeploy it. And it just started to pour with rain here, thunder and lightning. So now, obviously that SQL injection should no longer be there. Come back to that in a sec. Yeah, so that's gone now from the list, right? Which is what I expected. And if I come back to the command line, all these commands should not work anymore. So, you know, NS5, allow me to log in. Let's have a look. Just return back to the home page. So it did not allow me to log in. So that's it, Paul. I made it on time.
Wow, Lawrence, just want to make sure that I get what's happening here, right? So basically, the application was coded by a developer that failed to take into account the possibility of SQL injection attacks, and you basically demonstrated how you were able to, inject in commands that basically get the web app to accept any users to log in, right? And then by running it through the Snyk IDE, it actually automatically detected the potential problem and allow you to rectify it, before even you roll out the app, to the live production environment, presumably.
Sorry, I was on mute. Before you even commit it to the source control system, right? So this can just be live code that you're, building out, and in real time you can get feedback before you decide to commit into Snyk. So Snyk allows you to do it there. It also allows you to do it at the source control system as well. Like, for example, you might be in the AppSec team. You don't want developers checking in any code like that. So you can have PR checks. So when they do a pull request to merge their code in, at that point, it blocks it. Now, this is where you need to worry about the sort of balance of sort of over blocking developers from doing their work versus how secure you want to be. So it's a maturity thing. But I would say any critical high vulnerabilities you want to stop immediately.
Right, and I think you kind of answered John's question, which I just put live. I mean, he's asking whether this is a static scan, and I think you kind of alluded to the potential of checking at various points, right?
Yeah, that one I do is the static code analysis, but in production, as I said, we can scan things like containers at runtime.
So you can do either static as well as on runtime.
Yes, we're not. We're more on the development side, but we do have some capability in the runtime piece. But I wouldn't say that Snyk is a runtime security company.
Got it. And thanks, Lawrence, for the demonstration. I mean, you make it look so simple. And I mean, we are almost out of time, but I guess we got time for one or two quick questions, right? And I'm just wondering, right? I mean, especially the last one on the SQL injection. I mean, are developers so bad at securing their code? I mean, isn't it something that, should we just throw them to the security boot camp and all will be well? Does that work?
Yeah, I mean, I'd be careful with that language. I wouldn't say that developers are bad at writing secure code. I think it's a case of developers not knowing the hidden risks, right? They haven't been educated on it. Maybe they've never been taught, right? Like I remember back when I was developing, no one really explained to me how to write secure code. So I just did what I usually did. But that's why you need tools, right? But some organizations have your AppSec team or your security champions team providing constant workshops and enablement around this stuff to help developers. But generally speaking, if you look at a developer's job, their job is to get features out the door as quick as they can for the business and make sure they work. Security isn't really part of that equation. I mean, it should be, it has to be going forward, but it hasn't been up until recently, right? So it's not part of the developer's muscle, if you will. So it's not their fault. I mean, in reality is also that not every application is perfect. Like even the best developers in the world at Google or whatever would still introduce vulnerabilities. That's just the reality of what it is. And particularly if you're using open source libraries, as we said, all those thousands of lines of code potentially running in your applications, you have no idea where they're downloaded from on the internet. And hackers use very sophisticated techniques to inject malicious libraries into those package managers that you don't even aware of, using like slightly different names of well-known public libraries. They call it typo squatting, so that you inadvertently, if you do the typo, you pick up the wrong library. You didn't even know.
Got it. Thank you, Lawrence. And maybe just one last question, right? Before we wrap up for today. And what do you reckon? How do you think organizations can better support developers? And enhance their overall efforts to secure the applications. I mean, you alluded to part of it, in terms of the culture. And what else can organizations do today?
Yeah, I think one of the good things is the Security Champions program. Actually have dedicated folks who understand the engineering practices, but also the security practices. So that could be either a developer who is more curious about security and wants to sort of change focus to help educate other developers around security, or might be a security practitioner who wants to understand more about coding and software engineering and the sort of deployment SDLC. But in either way, you have those talented people in your organization. It's about cross-skilling. And then those folks are responsible for supporting, enabling, providing the guidelines and the tooling and infrastructure for the developers to do their job, which is, get features out the door quicker, but in a secure way. So it's more, they play a supporting role rather than a sort of enforcing role. Does that make sense? Are you on mute?
Yeah, I was on mute. Right. Thank you so much. Right. And our time is almost up. Right. Thanks, Lawrence. And for the rest of us, thank you so much for joining us today and for your participation, right, by asking the questions along the way. Lawrence, do you have any last comments you'd like to share? I mean, for those of us who might have further questions, who can they approach?
Yeah, I've just got one more slide to show. Let me do that. Let's get it ready. There we go. Yeah, so if you want to try out Snyk, just go to snyk.io and sign up for free. It started importing projects from GitHub. It's free forever account, but do give us a call if you want a demo. I think there's a link on snyk.io homepage. If you want a schedule a demo, just click that. Also, I want to recommend a very interesting podcast that our co-founder is running. It's called The Secure Developer. Fascinating. He invites many sort of CISOs and DevSecOps advocates from various companies around the world to discuss, what they're doing around application security and DevSecOps culture. And you'll learn a lot from that. And then finally, Guy Pajani himself, the co-founder, also has written a book on cloud native application security. What that means in today's world in the cloud. The cultural aspects, transformation, tooling, everything you can think of. It's a short read, only about 80 pages, but well worth the read to get you started on this journey. With that, thank you very much. Have a great weekend.
Thank you, Lawrence. And thank you all of us for joining us today. I think you have been a really good audience. Barely anyone left midway. So you have a great weekend ahead. Thank you, all of you, and see you. Bye-bye.